Hey guys, welcome to week 6 CAD guide. Today we'll be talking about assemblies. Really just taking the parts we've been working to create and turning them into a more mature version of your design. Um, as such, we're not going to focus on creating parts this week, so go ahead and download these pre-made parts from the link provided, um, and we'll just work on adding relationships between them for an assembly. Assemblies are in 3D space, so you got some more constraints to worry about than you typically would in if you said like a sketch. Um, but because of that 3D freedom, sometimes you don't really want to fully constrain your parts, and you'll see that in the future. So getting started on this assembly, we'll just go ahead and select the new assembly button on the Inventor home screen. You could either do that or through the new drop down the top left. And here we have our default view. Not a lot going on because we don't have any parts in the assembly, but you'll see later on. This cube is very important for navigation around your assembly, getting different views on it. You'll want to take some time to acquaint yourself with the new tools in the assembly tab. You have some old friends like plane and whatnot, but you have some new ones like constrain and joint that we'll talk about later. So to get started with the assembly, you typically want to place some parts in it. So let's go ahead and do that. In that zip file you should have downloaded, there are several parts within it. To start off, let's just grab the drive shaft. Now you'll see it's this translucent looking part. That just means you can click and add the part as many times as you like. For this subassembly, we only want one drive shaft, so go ahead and click once. You get that solid, opaque version of the part. And then we'll hit right click OK to say we're done placing parts now. Let's take a quick look at the part tree on the left here. You can see we already have that drive shaft replaced. We have the same origin features, like the different planes and the axes available to us. You can also see the drive shaft had brought in its own origin, as well as a work plane. That work plane will be useful later on. But it's good to know that parts can really bring in work planes or projected geometries, even to assemblies. Looking at these different folders again, origin, um, representations will give you different um, views if you want to hang on to those and save those for later. And the relationships we'll see in a bit here. So let's get started on actually creating this subassembly. We already have the drive shaft, so let's go ahead and throw in a retaining ring. That's going to be the 976 part. So go ahead and double click that and drop that in there. Let's go ahead and place a key. There we go. All right, drop these next two parts in without grounding them. You'll see in a second what grounding is. It's pretty important for assemblies. When we ground this drive shaft, so grounding is really just telling Inventor, hey, this part is my origin. This is the part that defines the base of my assembly. I don't want this to move. I don't want to be able to drag it. This is it. So we ground this drive shaft, and that is now our kind of base of operations. And it's going to be on this drive shaft that we start constraining our parts. So let's go ahead and add those constraints. Using this constrain tool up at the top here in the assemble tab, we're going to start taking a look at what's available to us. Typically, you'll be using this mate type. However, there are several other types. They're a little niche, but when you find one that works for your situation, it does a lot of the heavy lifting for you. Now let's go ahead and mate, using the constrain tool, our key to this drive shaft. Now the drive shaft slot is actually on the other side, so we'll use this cube up here to rotate around. And there we go. We're now looking at the correct side of the part. You could also hold shift and click in your middle mouse button. That gives you a lot more freedom. You just gotta be careful because you can get a little disoriented if you're not really precise in what you're trying to do. So the first selection on our mate will be this face of the part. You can tell you're selecting a face because there's this perpendicular vector coming out, and if you rest on it for a bit, it'll pop up that face normal option. So clicking the face of the key, and then clicking the interface of this keyway here. See, once again, you have that perpendicular vector, and there we go. That'll snap right into place. You see we're still using a mate. Um, we are using the default mate solution. That just means that those two vectors that you saw should now be opposed and directly connected. You could use an offset to back them off of each other if you wanted to. We're not using a flush for this one. The flush is the other solution, but you'll see that later on in this CAD guide. We're going to go ahead and hit apply instead of OK because we have some other constraints we want to do. Now, if we look at it head on the left view here, we can see the key's not actually centered. It's not in that keyway properly. So we're going to constrain the left side of that key using this vector here, perpendicular to this face, to, let's see here, let's see if we can get a view of it, to this left wall. Yeah, there we go. The left wall of the keyway. Now you can zoom in like I did and really get what you want. Or you could, of course, right click, hit OK, get out of the constrain tool and move that part out of the way to really get a good fix on it. But it looks like we got the correct constraint here. It doesn't look right yet. It is, however, centered in the keyway, and the key is pressed up against the face of that keyway. The only thing we're missing here, and you'll probably see it better if I turn on Shaded with Edges. This is a really powerful visual style. In most design reviews, they'll ask you to turn it on, but it's really useful for seeing the differences in parts. You can see the key is too far up. It actually should be further down. And to do that, we're actually going to use this work plane that came in with the drive shaft. So heading back up to Assemble and Constrain, we're going to grab right here, let me zoom in on it. We're going to select this work plane as one of the faces, and the top of the key as the other face. Now, I didn't update immediately because Inventor is in fact confused right now. Right now, it wants to put these two vectors in opposing directions, which, if you can imagine rotating the key upside down to make that happen, you can't exactly do that because we've already constrained the left side of the key to the left side of the keyway. However, if we chose flush, it can do that because putting those two vectors in the same direction as each other, that is possible without breaking any other constraints. So we'll go ahead and hit OK on this one. Well, hit apply by accident, but there we go. So now the key is properly constrained. It's in that keyway there. And in fact, I believe you can, I won't move that around for now. But yeah, you can't move that around. That is firmly constrained in there. The flush solution allowed us to do that same direction constraint, which we could have done in a different way is we could have rotated our camera and grabbed a vector perpendicular to the bottom of the work plane and then selected the same top of the key and then chosen mate. That would have also worked. However, we want to see how we can use both solutions. So now let's go ahead and get the retaining ring constrained. First, we're going to try and make it coaxial with the drive shaft. That just means that the center axis of this retaining ring should be the same center axis of the drive shaft. We're going to go right back to our constrain tool up here. And actually, to get this center axis, select the inner face of this cylinder here. And you can see in the center there, a vector appears. And in fact, a little tooltip pops up because I hung out too long on the retaining ring axis. So we are in fact selecting an axis by pressing this inner face here. So that's our first one. And then to get the center axis of the drive shaft, you simply just click on the outside face of the cylinder. And if you zoom out a little bit more, you can probably see the vector itself. Yeah, it's a big vector there. The visual on this slide here doesn't really do it justice. But yeah, we can see that arrow starting from the top of the cylinder and going all the way through it. That is also another axis. And by selecting both of those, we actually see the solutions change. We're not getting mate and flushed. It's now asking us, when we constrain these two, should those two axes be in the same direction, if we're choosing aligned? Should they be in opposing directions, if you choose opposed? Or this third one, which is actually really useful. It says, I don't care. I just want them to share the same axis, but the direction is flexible at this point. We're going to choose that because it gives us a lot of freedom. There's ways to use either opposed or aligned. It takes a lot of forethought to figure out what faces you should be mating. And in our case, the retaining ring is symmetrical depth-wise. So it doesn't matter if it's on one side or flipped upside down. So we're going to go ahead and apply that. Next up, let's go ahead and actually put the retaining ring in the groove we cut out for it. Because right now, it's actually phased into the drive shaft. To do that, we're going to do the same thing we did before, mating this face to this face. Now, if we're mating it, you should imagine the retaining ring is going to flip upside down before it goes into that slot. It's going to do that because those vectors you can see there need to be opposed for a mate, right? If we did a flush, that wouldn't work though, and I'll show you in a sec here. So choosing these two, it goes up there and it flips. If you chose flush, it actually puts it again within the drive shaft. Now, if you can imagine, we make these two faces parallel. However, flush tells it we want these in the same direction, these two vectors in the same direction. To accomplish that, it puts it within the drive shaft, just below the slot there. So in this case, a mate is the best choice. You go ahead and hit apply on that. And let's take a look at our feature tree on the left here. They're not features though. They are in fact relationships. So if we go back to the key and take a look at some of the things available there, we can see our first mate. Let's go ahead and rotate that around here. Our first mate, the one that put it in that keyway, is highlighted when you mouse over it. Second mate, put it justified to the left wall there, is highlighted. You have a better view of it here, highlighted. And the third flush that put it on the y-axis, up and down correctly, is highlighted here. A really cool thing you can do, and I really suggest it for whatever parts you're working on or whatever assemblies, is if you got time, just name some important relationships. Maybe not for the keyway because these are very simple, but maybe for the retaining ring. Just naming some of these relationships will make it easier in the future to identify problem ones or to identify ones you may want to remove without having to mouse over each one and see what each one does.